Hi, my name is Muhammad FARIDZUAN bin AHMAD. Name is
So there are a few things that we gain from the research is that first, to illustrate the significance of chromatography in blood processing, second, to discuss the various applications of chromatography in blood analysis and processing, third, to explore the latest advancement, future trends in chromatography related to blood processing. What actually chromatography is? First, we got stationary phase, the phase that stays fixed in place inside the column. It can be solid or liquid coated on a solid support. Next is mobile phase, which is phase that moves through the stationary phase, carrying the components of the mixture with it. It can be liquid chromatography, or a gas as a gas chromatography. Other than that, just for extra information, chromatography must need a separation that based on differential affinity, compounds with higher affinity for the stationary phase move slower, while those with higher affinity for the mobile phase move faster. Meanwhile, the retention time is that the time for the compound to pass through from point of injection to detector.
For the next slide is about type of chromatography. The first one is absorption. In this process of absorption chromatography, different compounds are absorbed on the absorbent to different degrees based on the absorbability of the component. Here also a mobile phase is made to move over a stationary phase, thus carrying the component with a higher absorbability to a lower distance than that with lower absorbability. This is the main type of chromatographic technique that are used in industry. The second is thin layer chromatography. In the process of thin layer chromatography that we call as TLC, the mixture of substance is separated into its component with the help of a glass plate coat with a very thin layer of adsorbent such as silica gel and alumina. The third one is column chromatography. Column chromatography is the technique used to separate the component of a mixture using a column of suitable adsorbent packed in a glass tube. Depend upon the degrees of adsorption of the component on the wall adsorbent column. The separation of the components takes place. The component with the high adsorbability is retained at the top, while the other flow down to different higher accordingly. The last one is partition chromatography. In this process, a continuous differential partitioning of component of a mixture into a stationary phase and mobile phase take place. The example of partition chromatography can be seen in paper chromatography. In this process, chromatography paper is used as a stationary phase, which is suspended in a mixture of solvents that act as a mobile phase.
So now I will be discussing the key advantage of chromatography, a powerful analytical technique. First, chromatography offers high precision and accuracy. This technique provides precise separation of mixture components, ensuring the substances are accurately identified. It also enables reliable quantification of compounds, which reduce errors and analytical results. These qualities make chromatography an invaluable tool for achieving reliable analytical outcomes. Next, chromatography is highly versatile. It can be applied to various sample types, including gases, liquids, and solids. This technique is utilized across multiple fields such as pharmacy, environmental testing, and food safety. Chromatography supports different chromatographic techniques like HPLC, GC, and TLC, and it is adaptable to both qualitative and quantitative analysis. This versatility allows chromatography to be used in a wide range of applications and industries. Finally, chromatography is known for its high sensitivity. It can detect minute quantities of substance, making it possible to identify trace elements and impurities. This technique enhances the analysis of low concentration samples and improves detection limits in complex mixtures. High sensitivity is crucial for analyzing samples with very low concentration, ensuring that even the smallest amount of substance are accurately detected. So now I'll be discussing some of the key disadvantages of chromatography, despite its many advantages. First, chromatography is associated with high cost. The equipment required for techniques like HPLC and GC is expensive to purchase. Additionally, the consumables such as columns, solvents, and detectors can be quite costly and need to be regularly replaced. On top of that, there's the ongoing cost of maintenance and calibration of the equipment, which adds to the overall expense. These factors make chromatography a significant financial investment. Next, chromatography can be time-consuming. The process often begins with lengthy sample preparation, including steps like filtration and extraction. The actual separation process can also take a significant amount of time, particularly for complex mixtures. Once the separation is complete, analyzing the chromatographic data and identifying the separated components can be very time intensive. All these steps together make chromatography a relatively slow process. Finally, chromatography requires technical expertise. Operating chromatography equipment involves specialized training and technical knowledge. Interpreting the chromatography results and accurately identifying the peaks requires a significant amount of experience and expertise. Additionally, troubleshooting any issues with the chromatographic system can be challenging for inexperienced users. This need to technical skill can be a barrier for many potential users.
And now we go to the example experiment of this topic, and I'm going to explain how blood typing is done using chromatographic separation on antibody treated paper. This innovative method is a quick and effective way to determine your blood type. Let's go through the process step by step. Step 1. Preparation of antibody treated paper. First, we prepare a special paper with specific antibodies. These antibodies are anti-A, anti-B, and anti-D for the RH factor. Each section of the paper is dedicated to one of these antibodies. Step 2. Application of blood sample. Next, we take a small sample of blood and apply it to each section of the antibody treated paper. Step 3. Chromatographic separation. Now, we introduce a solvent or buffer that moves through the paper by capillary action. As the solvent moves, it carries components of the blood with it, separating them in the process. Step 4. Observation of result. As the blood interacts with the antibodies on the paper, agglutination or clumping occurs if specific antigens are present. This movement or pattern of separation on the paper helps us identify the blood type. And last, we go to the interpretation. By observing where agglutination occurs, we can determine the blood type. For example, if agglutination happens in the section with anti-A antibodies, but not with anti-B, the blood type is A. If agglutination occurs in both sections, the blood type is AB. If no agglutination occurs in either section, the blood type is O. And RH factor determination or reverse typing. We look at the section with anti-D antibodies. If agglutination occurs here, the blood type is RH positive. If there's no agglutination, it's RH negative. In summary, this method offers a simple, quick, and portable way to determine blood types, making it especially useful in field setting or resources limited environment.
Okay, for my part is conclusion for chromatography in blood processing. Chromatography is a vital analytical technique in blood processing, offering precious separation and purification of various blood components. Its applications are diverse, ranging from diagnostic testing, where it helps detect and quantify biomarkers and drugs in blood sample, to therapeutic protein purification, ensuring high purity products such as monoclonal antibodies and clotting factors. Okay, chromatography also play a crucial role in blood fractionation, separating blood into its components for different therapeutic uses, and in monitoring drug level to ensure accurate dosing in treatment. Overall, chromatography significantly advanced medical diagnostic and therapeutic, enhancing patient care and treatment outcomes.